your viewing pleasure, I have a Ross 400 watt power amplifier in for service. This amplifier is 200 watts per channel. It's a stereo amplifier that can be operated in bridged mode, so it can be run as a monoblock 400 watt amplifier, and or stereo is 200 watts per channel. And what I've been told is the B channel is distorted and the output is low. So we're going to hook this thing up to a signal generator, we're going to hook it up to a scope, and we're going to look at the signal coming out of it and see what it looks like. Now, these units being a dual mono design, we're going to find in here two completely separate amplifiers. Our A channel is on this side and our B channel is on this side. There's actually two separate power transformers on this, two completely separate power supplies. These units are built as a dual mono design. So because we know the problem is only on one channel, well, all we really have to look at is what's going on this board here. The complaint is that the B channel is much lower, and it is. You can see it. Even though the function generator is noisy, you can see all this noise. See here? We have a bad transistor or something on this, or maybe even a bad cap. But I'm going to go out on a limb and say it's probably a bad transistor. So the first thing I'm going to do is I'm going to get my cold spray out, and we'll just hit a few of the transistors with cold spray and see whether it'll clean it up at all. It's definitely something. Oh, it just came up. It just came up when I tapped the board, and it just cleaned up. Interesting. Besides the fact that that control is a bit dirty. Shut it off for a minute here and just let it cool down. We may have a thermal intermittent transistor on this thing because it was definitely distorted. It was definitely distorted until I started tapping on the board right in about this area here, and the waveform cleaned up. It was really dirty and distorted prior to that. And while I've got the amp off, I'll use this as an opportunity to get in here with the contact cleaner and just give the controls a little shot of cleaner and clean the controls up. Just gonna tap. Duster and invert it. It's a poor man's way of getting frost. I don't know if there's anything left in this can or not. It might be almost. Oh, I think this can's empty. This can is empty. I gotta try and find another can of frost. So we have another can of frost here, and I'm gonna just try and spray some of these transistors down here and see where distortion comes back. these, might have been one of these plugs that was not seated properly. Again, ignore the flat tops on here. That's my audio generator. It's just not outputting a nice true sine wave. What do you expect? This generator was made in the early 1960s. About the same vintage as my scope that I use as a clock. That's got a fan that's loud enough to wake the dead. One of these days I'll haul that thing down and put a nice little quiet fan in there so that I can actually turn the thing on in my workshop without it annoying me with the noise that it makes. I think what I'll do on here is I'm just going to turn the power off, discharge the capacitors. I'm going to take a look at this board and see if I can see any connections that may be suspect on it. Because as you saw, it was noisy and distorted until I tapped, and then it went away. So we may have a cold solder connection in there that's now corrected itself. So to access the bottom of the circuit board on this, we're going to remove this bottom access panel. One nice thing about these power amplifiers, all these ones that are made for the serious high-end consumer or for professional use, they're designed for ease of servicing. One of the problems with a lot of the lower-end consumer products is that they didn't provide access panels like this, which made some of the units, especially some of the ones made by, I don't know, companies like Techniques and companies like Yamaha, they were very difficult to actually do any work on because they weren't designed to be repaired. We have some major leakage happening. It looks like from one of these capacitors that maybe I should be investigating to replace. If you look on the bottom of here, you can see all the crud that's been leaking out of it, and it's been leaking out of this cap right here. Yum. We have a capacitor here that is looks like it's a cap. It's spilling its guts. It's one of the big filters. They probably both should be replaced. I'll be contacting the owner of this thing and just letting him know what I think we should be doing on this thing. These are going to be big, and they're going to be not inexpensive, but here they are here. We got one of these big filters is leaking and the tops are bulged, so I'm going to recommend, before I even go any further on this unit here, it can sit on my bench apart for a while, but I'm going to contact the owner of this unit. It's a musician, he uses it for gigs, and I'm going to recommend that we replace the filter capacitors on it, because when you've got electrolytic leaking out of a capacitor, its days are done. It needs to be replaced. So, but let's take a look and see if we can find anything else wrong with this thing before I go down that road. One thing I see when I look at this board here is the soldering on this board is actually not that good. If you look around in here, right in here, this connection doesn't look to be really great there. This board looks like it was hand soldered is what it looks like. And whenever you have equipment that's been handmade, you run the chances that it's good. There's going to be some quality problems where things just aren't done as well as, say, machine assembled. What I'm going to do is I'm going to fire this amplifier up without my speaker load on it, because I don't want to blow my speakers in the event that we get a DC voltage out. I'm just going to scrape the back of the board here with a non-metallic screwdriver, like the butt of a screwdriver, and watch the scope and see if I see anything jumping out at me. It'll be under no load, but I should still be able to get a reading on the scope. I'll just load it down with a resistor is what I'll do. So here we have our output. I've got it loaded into an 8 ohm resistor. And I'm just looking at the output here, and I just want to just tap around on here and see whether, when I'm scraping around on the board here, I'm going to get some distortion come up here. We can take the amplifier up to full rated power, If I take the amplifier, I've actually got it running at almost full rated power now. If I continue to turn up the volume, you'll see what happens to the waveforms here as we get into distortion. Let's see if I can get my scope to trigger properly here. There we go. As I go up higher, you'll see what happens. You see, now we're getting into clipping. And the clipping light has now come on the amplifier. Clipping light is just starting to come on now. So we're just at that point where we're just starting to clip. So we're back on the Big Ross Systems Mega Amp 400. I was all set to replace the main filter capacitors on here because, as I showed you before, it appeared that there was something leaking from the capacitors. Once I pulled the cap out of the board, I found that it actually wasn't something that was leaking from the capacitor. It was something that had leaked onto the top cabinet and had run down the side of the capacitor and had dripped onto the board and had exited out. There's a small hole on the bottom, which is where the vent would be, directly on the center of the capacitor, and it actually had not leaked out of the capacitor itself. So we put the caps on the capacitor meter here, and they're 10,000 microfarads. They're kind of up around 9,800, 9,900, which is pretty darn close to where they're supposed to be. I was going to change them on good measure just because of the age of them until I went down to the local supplier, whose computer said that he had plenty in stock. And after I made the special trip driving 50 kilometers to the local parts depot, only to be told, oh sorry, the computer is not up to date and we really don't have any. And you know, so anyway, I'm back here working on this thing here, and what we found on this unit, there was some of these interconnect plugs here had come loose, and I did it off camera, so I don't have the actual footage of this when I was working on it, but we had a low channel, and when I moved some of the plugs here, the level jumped back up. So I inspected the board. I'll show you the bottom of the board. I think I showed that previously, but there was nothing found connection wise. Nothing looked bad on here, other than the fact that when I moved one of the plugs like this, I think it was this input plug here, the levels had jumped up. So basically there's not a heck of a lot wrong with this thing, other than the fact that, and this is something to keep in mind whenever you have any of these devices that have got these plugs. Plugs are a big source of problems. So if you have plugs that come loose, they can cause intermittent problems. So sometimes it's a good idea to just undo the plugs and reseat them. That way you know that if there's any corrosion or any oxidization on the pins that's built up over time, by just unplugging them and plugging them back in like this, a lot of times you will clear that trouble. Is it going to be a permanent fix? Probably not. One of the biggest problems with modular designs, and anybody who's worked on any Zenith televisions can tell you lots of stories about the problems with the modular design. Zenith had their Chromacolor and Chromacolor 2 solid state sets, which had these little plug-in modules, and it was designed to make repairing the set easy. And all these little plug-in modules did was ensured that it was a revolving door to the repair shop, because they would go bad on a regular basis. So I'm just going to reseat the rest of these plugs on both sides of this unit here, both channels, and we'll send this one on its way because there really doesn't appear to be much wrong with it. Okay, I've reseated all the plugs, everything is tight. I've got a source plugged in to both channels, a stereo source. We'll just power this unit up, and we'll see that our levels are good on both channels. I really can't cut this thing loose because these small PSB speakers are only rated at about 50 watts, so I can't cut a 200 watt per channel amplifier loose on this thing, or I'll end up with speaker fragments all over the garage here. But what I can do is I can put it into a load and open it up on the scope, and we'll take a look at how the program audio looks with the speakers disconnected into a load. So we now have the amp connected to a load. We'll crank this sucker up. We have a peak indicator. This is the channel that was supposed to be weak. As you can see, we have lots of power here, and we are now getting to distortion, or the peak light is coming on, so you can see that we are actually starting to clip a bit here. This is where you can see the clipping. If I go into clipping, you see that? That's distortion. So we are running at a good half volume here. We are running into a resistive load, and I have a resistor on here. I also have an incandescent light bulb on here to take the load, as you will see. If I pan the camera up, you'll actually see the light will start to flash. You can see it there with our program. So as we are getting up to full power, now that takes 130 volts obviously to light that light up, but we are running pretty much full load on this amplifier right now, and we'll run this for a while and see if she gets warm. So as the next piece of music is about to begin here, you'll hear it coming out of my TV. This is just my demo disc that I use for when I'm working on monitors. So we're going to run this amplifier at full power. What we're looking at here is we're at 5 volts per division. So as you can see, we'll go to 10 volts per division because this thing's going to have some pretty good kick when the music gets going here. So for every division on here, that's a 10 volt swing. So this is your baseline, so you got 10 volts plus, 10 volts minus. Slow that down a bit so you can actually see the amount of power that this amplifier is going to put out here. And it's going to put out a fair bit of juice here. I've got it set to just a point where the clipping, the peak light will start to come on as we start to get into clipping. But as you can see, the amp is putting out plenty of power. On this 10 volts per division, 10, 20, 30, 40, 50, 60, 70, so that's about 80 volts. When you get a peak from one extreme to the other, that's an 80 volt swing that we're seeing here. The light bulb that's being used is a 130 watt bulb, or 130 volt bulb, sorry, so we'll never see the light light up like you would if you plugged it into a light socket, but as the voltage gets up there, of course, you will see you'll see the light start to flash. So here we go, music building up again. Here we go, we got maximum peaks here. We're not even at maximum output here. If I turn this thing up, okay, now we're starting to get into maximum output. And if I show you the old light bulb is starting to modulate with the program. Now I'm only testing the one channel on this amplifier because the complaint was just channel B. Channel B was the one that was the complaint was. So we're getting to our peak power level here. So now what we've done is we've put both channels are being driven to maximum output. I've got a second source, a second load, which this case is just a 50 watt halogen bulb. Probably recognize this one. This is the one I used to fix my stereo to reflow the BGA mounted DSP chip that the solder had failed on. Anyway, that's still working. Okay, we have two channels going here. We have the channel 2 is this one. This one's channel 1. Just kind of got them reversed, but I'm monitoring both now. I've got both levels set to the point where we're going to be at close to maximum output, and both channels are both loaded into an incandescent light bulb, which gives us an even load. Yes, I realize it's not a dynamic load like a speaker would be, but it is a resistive load. And what we want to do here is we just want to run the amplifier into a dummy load, a resistive load, to see how it performs, and more importantly, make sure something doesn't fail under load, which I don't think we'll have any problems that I can monitor the waveform here on the scope. So we're going to let this run here for a few hours and just monitor the operation. So we've had the amp now running for about 3 hours, and like there's no heat at all. This thing's been running at maximum output now for the past 3 hours. You can see the light glowing away here. No heat. Transformers are just slightly warm. There's no heat whatsoever off this thing. This thing's a real brute, and it puts out lots of power. And I'll say that I'm going to declare this repair a success. So remember, I had severe distortion on one channel when it came in, and the right channel here, channel 2, was about half the level. Just reseat all the connectors. Looking at the board, everything else looked good on this thing. Really couldn't find much wrong with it, other than had to clean the controls and reseat the connectors.